Hey, Year 9. This could well be our last recorded remote lesson. Hopefully, we're all back in school next week and we can start getting back to normal. So, in today's lesson, we are looking at landforms again, but this time we're looking at those landforms that have been shaped by glacial deposition. So, not by the massive forces, the ice wearing away at the rocks, but this time when the glaciers melt, when we either naturally or because the climate is changing and getting warmer and there's lots of melt, we get landforms and features that we see in the countryside that are formed by this process. So what we're going to look at today is identifying and describing glacial depositional landforms, and those are called moraines, glacial till, erratics, outwash plains, and drumlins. So we're going to look briefly at what those things are, and then you're going to get to do some work on how they're formed and what they look like. So first of all, I mean, it's worth remembering that ice sheets and glaciers carry huge amounts of debris, all the stuff that they've worn away from the sides of the valleys through things like plucking and abrasion. It all ends up in the ice, under the ice. And then when that ice melts, as it naturally does, following the end of an ice age or just because of increases in temperature, then the ice can no longer carry all that material. So it therefore loses energy and it's got to get dumped or deposited is the proper word we use for that. Now, all that material is called glacial till, and it's a random mixture of boulders, rocks, sand, and clay. So as well as that glacial till, we actually get some landforms that you can actually see in the countryside, especially where the edges of glaciers and the edges of ice was in the past. So most of this deposition takes place in warmer lowland areas where you get a thick layer of till, glacial till, and it happens because of two things. Some are because of the ice melting and they get left behind, and some are because of the meltwater flowing out from the glacier and carrying material with them. So we're going to look at some of these landforms. So make sure you watch the video carefully, and obviously when we come to do the activity, you may need to go back and watch certain bits again, but see how many you can actually do from memory. So take it in really well the first time, and that might avoid you having to go back and read back over it. Right, so the first two landforms that we see, one is really cool. One's called erratics. Now these are these huge boulders that sometimes are found miles away from the same rock type. So basically they've been carried by a glacier and they may have been carried several miles and they just sat there, and they're huge boulders which don't fit with the surrounding landscape. And now for many, many years, people didn't know how they got there or why they got there. And it was only when we started to understand the science and geography of glaciation that they realized that they'd been carried there by ice which had since melted and left them there. And these are called erratics. The other landform that we see are these sort of mounds which are called moraine. Now moraine is basically just the debris that has been left behind when the glacier has melted and retreated. And we'll look a little bit more at moraine later on. Okay, the next landform that we see sometimes in the landscape are drumlins. Now these are smooth egg-shaped hills, and they can be anywhere between 100 and 800 meters long and anywhere between 25 and 100 meters high. And you usually get drumlin fields where you get groups of them around a flat valley. And basically these have been left where the glacier has been moving, and at its base it starts to drop material, and then it leaves these mounds, these sort of small hills of glacial till behind. And they have a steep end at one end and a shallow end at the other. So they look a bit like half an egg in the landscape. Now I've already mentioned that glacial till is the material that's made up of rocks and clay that you get. Now we also get features called outwash plains. So when the glacier melts, streams flow away from the glacier, and these streams can be huge because they're all that meltwater as a glacier melts and they carry lots of debris, and they drop the heaviest, largest debris first, and then as they get further away from the glacier, they eventually drop the smaller materials further away because of the less energy, less carrying capacity. So those are two more of the landforms. Okay, so now what I'd like you to do is draw yourself a table just like the one here. So 3 columns, glacial deposition landform named in one of them, a description of that landform, what it looks like in the second, and then a brief explanation of how that landform is formed, how is it created in the third. Now the 4 landforms that I want you to talk about are above me here, so erratics, moraine, drumlins, and outwash plains. Now see if you can have a go at describing and explaining them from memory, but then if you do need to go back, then just rewind the video a little bit and just check that your understanding was correct of those 4 landforms. So this probably would take you about 5 to 10 minutes. So if you pause the video, complete that task, and then we'll be ready to move on. Now, when we were talking about these landforms earlier, I mentioned that one of them was called erratics, and obviously you can now explain how those are formed. Why do you think they have the name erratic? Think about where the source of that name, if you were going to use the word erratic in a normal situation, what would that mean? And why do you think those rocks, which don't belong there, are called erratics? And then secondly, why do you think meltwater streams are so powerful and able to transport so much of this debris away from the glacier? Just spend a few minutes thinking and just answering those questions. Right, so earlier on I did say that we were going to look at moraine in a little bit more detail. Now, moraine is the material that's carried by the glacier as it moves down a valley, and moraines have different names depending on where they are found in the glacier. So we're just going to look at those different types of moraine and talk about why they belong and why they are where they are. So first of all, we have something called terminal moraine. Now the clue is in the name really. Terminal because it's found at the end of the glacier. So a glacier will grow and grow and grow during an ice age, and then obviously as temperatures warm, the glacier will start to retreat and shrink in size, but it leaves behind a mound of material at its snout, at its front. Now these are really useful because scientists can then see where that glacier was historically. As it moves back, they can see where it was, 10,000 years ago, 5,000 years ago, 1,000 years ago, and you've got that scientific record of where the glacier was, and we can see how quickly it's retreated. So terminal moraine is found at the snout, the front of the glacier as it moves back. The next type of glacier is something called lateral moraine. Now lateral means alongside, so lateral moraine is found at the sides of the glacier. So as it picks up material and plucks debris from the valley sides, it will collect that material and carry it with it at its sides. So if we find this sort of loose material alongside the edges of valleys, that is the lateral moraine. And then last of all, sometimes 2 glaciers will move down a valley and start to join, and the lateral moraine at the edge of them will merge and end up in the middle of a glacier. And this is called medial moraine. So a bit like medium, which means in the middle. Medial moraine is that moraine that's found in the middle of a glacier where 2 lateral moraines have merged together. And we can see all these shown here, the terminal moraine, the medial moraine in the middle, and the lateral moraine at the edge in this diagram above. Okay, so now what I'd like you to do is think about what we've just learnt about the different types of moraine. I want you to answer these 3 questions, A, B, and C. Again, this should take no more than about 5 to 10 minutes. Try and answer them in full sentences. And if you do need to go back over what I just talked about with moraines, that will definitely help you be able to answer the questions. So give yourself 5 to 10 minutes, pause the video, and then we're ready to move on. Okay, so last of all, I want you to think about all of the different landforms that we've looked at today. And I want you to draw a final table, this time with just 2 columns. So I want you to think which landforms that we've looked at, these depositional landforms, have been formed by the melting ice or the receding glaciers. And then which of them have been formed from the meltwater coming from the glacier. Now this is going to take you to think, you're going to think carefully about this. Would that landform exist if it wasn't for the ice moving back? Or is it actually the flow of the water coming from the glacier that's created it? So have a go. There should be 5 different landforms that you can add in here. And then once you've done it, take about 5 minutes thinking about it and filling that in. We will check those answers. Right, so hopefully you've had a chance to have a go yourself. Let's have a check and make sure that we've got these right. So first of all, we've got moraine. Now moraine is obviously formed, the moraine that you have left is formed when the ice retreats and you get left with terminal, medial and lateral moraine. So that will be formed from the melting ice. Next one is the erratics, these random stones that erratically appear a long way away from where they originally came from. Again, these are formed by the melting ice. They were carried by the glacier, and then as it melts, they leave behind these erratics. The outwash plains, obviously, they are formed in a different way. They're formed by the meltwater from the glacier, so they would definitely go in that column. Glacial till, so the material that's made up of all the debris, again, that is formed from the meltwater washing that till out of the glacier. And then last of all, we've got drumlins. And drumlins, again, are formed by the melting ice. So remember, they are small hills created when the glacier melts and leaves behind material, and they're often found in fields. So that would, as in drumlin fields, groups of them. And they would again be formed from melting ice. Right. So over the course of this topic, you've already now learnt about those landforms that can be found in places like Norway and New Zealand, but also in northern England and Wales, that are formed by erosion. But we've also got some examples of these depositional landforms in the UK and abroad as well. And what we're going to go on to look at potentially when we're back in school now is how we use glacial landscapes now. Okay, so a lot of the ice is gone from these places, but how do humans use those landscapes in the modern times? If you've got any questions, any issues at all, obviously email me or email your own teacher and we'll be able to give you some help where you need it. See you soon, guys. Bye.